Everything we've looked at, everything we've done, trig, polynomial, logs, natural logs, exponentials, all of those are what we call explicit. Explicit functions. They're all functions, right? They're all explicit. This is an example of an explicit. What we're going to look at today is implicit. Implicit. The easiest way to tell implicit is if x and y go together. You can see on the left one here, I know it's not blue on yours, but y is separate from x. Y stays over there, x stays over there. That's explicit. That's the way we're used to doing things, right? We live in an explicit function world. That's where we deal with those things, right? But sometimes x and y can play in the same playground. They're called implicit. Those are called implicit. So this is an example of x and y being on the same side. I have y cubed and y, and I have also x's in there, right? Over here, keep them separate. Keep them separate, solve for y. That's what we're used to. That's what we're comfortable with. Today we're going to look at guys like this, okay? These aren't functions. They're not functions. I'll show you in a second. Why are they not functions? They're not functions. It's difficult to separate x and y's. It's difficult to separate them, right? Sometimes it's easier than others, but it's just, what we do with these guys is I wouldn't solve for y if I was doing this guy. I'd solve for x, because there's only one x squared. So I would solve for x. So usually when those equations, those functions where you're solving for x instead of y, those are implicit, okay? So what would they look like if I were to graph them? Well, here's a couple examples. Explicit. I didn't put this in your notes, but it's just a visual. Explicit is what you're used to. Lines, parabolas, polynomials, right? That's what you're used to. They all pass what we call the vertical line test. The vertical line test means if I move my vertical line from left to right, I don't touch more than one spot. All right, for all of these guys. Implicit, these three pictures here, these are non-functions. How come they're non-functions? Well, let's look at the first one, the kind of bow tie looking guy. Right there, I pass twice, 2 spots. Fails the vertical line test. Same thing with this guy. Fails the vertical line test. Fails the vertical line test. It's not a function. Okay? So implicits are not functions. They kind of look like that. Explicit, you guys have been doing that since Math 1. Okay? So we're not going to look at these. We're going to look at these today. That's what they look at if we were going to graph them. Okay? You don't need to graph them. We're not graphing them today. You don't need to graph them, but it's always good to have a visual. What am I finding a derivative of? These guys. Okay? Okay, so in order to do that, we have to take a couple things into account. We're still going to use the same rules. I'm still going to use the power rule. I'm still going to use the quotient rule. I'm still going to use the product chain rule. All of those rules that we've done, I'm still going to use those, but they need to be modified a little bit. There needs to be a little bit of modification. Okay, so before we get to that, the dy dx, you've seen it lots and lots and lots of times. What exactly does it mean? What exactly does it mean? Or what does it refer to, I should say?
The derivative of y over the derivative of x?
It refers to, yeah, so actually what does it mean? If you want to translate it into words, this guy actually means it's the derivative of y with respect to x. With respect to x. So it means you're finding the derivative of y and you're living in the x universe. We do that when we're dealing with explicit. Everything is solve for x, solve for x, solve for x. When we live in that universe, you solve for x. That's what you always do, right? It's written on the board right now. Solve for x. That's what we always do, right? That's when we use dy dx. But today, we're not living in that universe. We're living in a universe where x's and y's can coexist. Okay? So how's that going to look? It's going to look a little different. Okay, so when we found the derivative, so of this guy, we would say dy over dx equals, right? And then what would be the derivative there?
6x minus 1.
6x minus 1, right? Just use the power rule for that. You guys have done that. We did that last unit, last chapter. That's what the test was just on. So now when we find the derivative of this guy down here, it's going to be a little different. How is it going to be different? Well, now x's and y's are playing the same playground. They're playing together, they're stuck together, they're intertwined. So let's find the derivative. Okay, some of it's going to stay the same. So how do you think I would find the derivative of this guy? What would I do to find the derivative of that guy?
Power.
Yeah, so what would the derivative be?
2x.
Agree. What do you think the derivative of this guy would be?
6y squared.
Negative
6y
6y squared. You're right. You're absolutely right. And then the derivative of this guy
4.
would just be 4, right? Positive 4 equals. And then what would the derivative of, oops, not equals, 2 be?
0.
0. So it would equal 0, right? You're right. With some modifications. Here's the first modification. Anytime you're finding the derivative of y or something other than x, you have to give it a little tag. You have to give it a little tag. What is that tag? So a little tag. It's dy over dx. So I found the derivative of y twice. Once in green, once in blue. So I have to have 2 tags. Why do I do that? Because I wasn't finding the derivative of x. I was finding the derivative of something else with respect to x. So let me ask you a question. Why didn't I do that for x? Kind of a trick question. So I found the derivative of the green, which was y, and the blue, which was y. So I just used the power rule, and then I had these tags. Why doesn't x get that tag? Kinda, you're getting there. Has something to do with respect. So it does actually have a tag. We just never write it. This guy, if I did it correctly, this guy also has a tag. What tag would this guy have? D something over D something. What did I find derivative of? X or y? With respect to x. Why don't I write that tag on? Why is it not required for me to write this tag? Because what is it equal to? 1, right? Isn't something divided by itself always 1? So that's why we never wrote the tag last chapter. Last chapter we didn't do it because it wasn't necessary, because it's equal to 1 if you do that tag. Over here it's not. dy over dx, they're not 1. It's something over something. That's why we write the tag now. We've never found derivatives of anything other than x. Now we're going to. Okay? So there's a couple other steps where we do. But we're using the same rules. That's the only caveat. Anytime you find derivative of something other than x, you got to put a little d. What letter are you finding the derivative of over dx? Okay, d something over dx. Okay? That's the only difference between what we've done in the past and what we're going to do today. So let's look at the first example. I'm going to color code this one first, so just so we're good. So I got 3 terms on the left side of the equal sign. I got 1 term on the right of the equal sign. I'm just going to find the derivative of each. What's the derivative of the yellow?
Negative 6y.
-6y to the first power, right? Does this one need a tag?
Yeah.
Yes, it does. It needs a dy over dx. So that's the derivative of the yellow. The yellows go together. Green. What's the derivative of the green?
dy over dx.
Yeah, 1 times dy dx, right? So -1 tag dy over dx. Because the derivative of -y is just -1. And then it needs a tag because I found the derivative of something other than x. Okay, let's do the pink one. What's the derivative of the pink? Plus 10x. Does this one need a tag? No, because I'm finding derivative of x. X's are okay. They don't need the tags because the tag would be dx divided by dx, which is just +1. Okay. Equals. What's the derivative of the blue?
-9y²
This one also needs a tag because it's derivative of y, or derivative of y. Okay. So now what I have to do is it says find dy over dx. Well, I have 3 of them, right? So what I have to do is get them on the same side and solve for them. Okay, right now I have 2 of them on the left, 1 of them on the right of the equal sign. I got to solve for them now. So what I'm going to do is I'm going to get everything with a dy dx to the right, or sorry, to the left. Everything without to the right. So the only thing that doesn't have a dy dx is positive 10x. So I'm going to subtract that from both sides. And then this guy, I'm going to add to both sides. Okay. Okay. The negative 10x with the positive 10x makes a 0. Negative y squared dy dx times positive or plus positive 9y squared dy dx goes away. What do I have left? Over here I have negative 10. I should be x. I don't know why I didn't put x. This should be an x. Okay. Can I combine any like terms? Can I combine the 9y squared dy dx with any of the yellow or the green? No, because they don't have a y squared dy dx. The yellow has a y dy dx. The negative one doesn't even have a y. They're not like terms. So I'm just going to put positive 9y squared dy dx minus 6y dy dx minus 1 dy dx. Okay. I have 3 terms. They each have a dy dx. What can I do? Factor, yeah, factor, right? GCF, isn't there GCF a dy dx? They all have it, right? That's called factoring. So I'm going to put dy dx in the front. When I take away a dy dx, what's left?
9y squared, no more dy dx. Negative 6y, no more dy dx. Negative 1, no more dy dx.
If you want it back, just distribute. Just do distributive property, and you get it back. But we don't want it. So now it's dy dx times 9y squared minus 6y minus 1. How do I get dy dx by itself? Division, yeah, division, right? It's this, the red times the black. What's the opposite of division? Or what's the opposite of multiplication? Division, right?
So what I'm going to do is I'm going to divide both sides by
everything other than dy dx.
the stuff that I want to not be there, because I want dy dx to be by itself. So dy over dx equals, anything divided by itself makes a 1, so all of this is a 1. So it's negative 10x divided by 9y squared minus 6y minus 1.
That's what the derivative is?
That's a derivative. It said, let's go back to the instructions. The instructions said, find dy dx. It's like solve for y, solve for x. That's what I just did. Okay? So the only difference between what we've done in the past and what we're doing today is, first of all, the tags. If it's not x, give it a tag. dy over dx, whatever the letters are. Today, it's just going to be x's and y's. And then get dy dx by itself. All right, let's look at the next one. Okay. I got one term here. I got one term here. I have one term here. I'm not gonna highlight 0 because 0 is just 0. The derivative of 0 is 0. So they want us to do the same thing, find the derivative. So the yellow, negative x y squared. How would I find derivative of that? Two words. Product rule, yeah, product rule, because it's negative x times y. So we're going to use the product rule. We're going to use the product rule, something you guys have done many, many times. Okay, so the product rule says the first times the derivative of the second. What's the derivative of the second?
2y times dy over dx.
2y. And since I found the derivative of a y, I got to put a tag. So this guy's going to get a tag. dy over dx plus.
Could you also write it as y prime?
Yes. Yeah, absolutely, yeah. Yeah, you'll see that sometimes too. You'll see that sometimes. The reason I write dy dx is to give it that tag is because that's the way I was taught, but I've seen this too. So instead of that tag, you can write a y prime tag too because it's the same thing. Yeah, it's the same thing. It's acceptable. So what Ezekiel's talking about is instead of giving it that tag, you can give it this tag, y prime. It's the same thing. It's the same thing, and then every time give it that tag. Whatever's easier for you. The reason I do dy over dx is because you see it all the time, dy dx, and because the way I was taught was to do it this way. Is it wrong the other way? No, it's just different. So yeah, you can absolutely use that. If that's easier for you, use it. Yeah, every year I'll have some students who just do that. That's fine, not a problem. Okay, so now I got to do the other one, right? So now we're going to go y squared times the derivative of x, negative x. What's the derivative of negative x? Negative 1. Does negative 1 need a tag?
No.
Because it's derivative of x.
Will we ever get an equation where y and x are switched and we're having respect to y rather than x?
No. But you'll get other letters. They'll use other letters. Instead of x and y, they use a and b. Or s and t. We'll get later on into the chapter, we're going to talk about like time. And they'll use, instead of x, they'll use t for time. But yeah, they'll never, like, just to mess with you, switch x and y. They'll never do that. That's just mean. X is x, y is y. But sometimes, like I said, when we're dealing with application problems, you're talking about time, and they'll use t instead of x. Yeah. Mm-hmm. Okay, so now we did. That's the derivative of the yellow. This is the derivative of the yellow. Now we got to find derivative of the green. The derivative of the green, just 1. Doesn't need a tag because it was derivative of x. What's the derivative of the pink?
0.
0, right? I'm not going to write 0 because it's just plus 0. Blue, what's the derivative of the blue?
3y squared times y prime.
Y prime or dy dx, yeah. Equals 0, because the derivative of 0 is 0. Okay? Now I got to isolate the dy dx's, just like I did the last problem. So anything without a dy dx is going to move to the other side. So the only thing without, actually there's a couple things. I can subtract 1 from both sides. And then if you look, this guy here too, negative y, it's really negative y, right? I can add 1y to both sides, squared, sorry. Okay? So that'll be here, that'll be there. So I get negative 1 plus 1y squared, right? 1y squared is just y squared. Thanks. All right, and then the other stuff comes down, comes straight down. Yeah, go ahead. So let's see, negative x times 2y times dy dx. Negative 3y squared times dy dx.
We can simplify dy dx.
Mm-hmm. Since they both terms have a dy dx. You got one term here, and you got one term here. Their GCF, actually their GCF is more than dy dx, but we just want to factor out the dy dx. So it's going to be negative x, actually you know what, I'm going to rewrite this. Instead of negative x times 2y, it's really negative 2 times xy. Minus 3y squared. Okay. Since what we want to isolate is being multiplied times the parentheses, we're going to divide by what's in the parentheses. Anything divided by itself makes positive 1. There you go. Again, the hard part about this, not the hard part, but the part I see mistakes isn't the calculus, right? We were done with the calculus after this. We were done with the calculus. Everything below that circle wasn't calculus. It was just isolating a variable.
Will they ever ask us to get like the second or derivative of it?
Yeah. We're going to do, when they're doing implicit, they're never going to do anything bigger than second derivative. Yeah, when they're doing implicit like this, that would just be mean. They would, we're going to do, the last two problems on this are second derivative problems. Yeah. Okay. All right, let's flip over. Let's look at example number 3. I want you to try this one on your own. Try this one on your own. Okay, so the derivative of the yellow is -3, and since it was a y, you're going to have a tag, dy over dx. The derivative of the green, to find the derivative of the green, it's x times y. I have to use the product rule. The product rule is x times the derivative of y. The derivative of y is 1 dy over dx. So you can put a 1 in there. It's not necessary, but you can put a 1 in there. Plus the derivative of the first, well, the derivative of x is 1 times the second, which is y. So there, again, there's another 1 there. There's a 1 there and a 1 there, but I didn't write it. You don't have to. You can if you want. Equals, and then the last thing was the derivative of the pink. That is just 3x squared. No dy dx because it's x. Okay? So the only thing that I see that does not, the only term I see on the left side that doesn't have a dy dx is the positive y, yeah, the plus y. So that guy, I'm going to move over here. To do that, I got to do the opposite. So I'm going to subtract y from both sides. Okay. So I have a -3 times dy over dx plus x times dy over dx equals 3x squared minus y. I got two terms on the left side of the blue line. They both have a dy dx. So I'm going to factor out a dy dx. So that's -3 plus x. Because once I take out the GCF, the leftovers are just -3 plus x. Divide by what you don't want to keep on this side. Done. Okay. Use the same rules we've been using. Chain rule, product rule, quotient rule. The only rule we haven't used, so we've used power rule. We use that all the time. We've used product rule right there, x times y. The only ones we haven't used are chain rule and quotient rule. We're going to use the chain rule on the next problem. Okay. So this guy right here, number 4.
Same thing, find dy dx. Yes.
Is the 2 attached to the x and the y? Or just the x?
Just one of them. So it could be attached to the y, it could be attached to the x.
It's like for the derivative of x, it would just be
Yeah, because if it was attached to both, it would be 2x and 2y. But it's just, yeah, just pick one. So we have this guy here. Well, this guy here, cosine of 2xy. How did we do that? Chain rule. So we're going to use the chain rule to find the derivative of this. So when we do chain rule, remember you do the outside. The outside is cosine of something. And then the derivative of the inside is that. So that's what we're going to do. We're going to use the chain rule for that. So the first thing I'm going to do is find the derivative of cosine. Negative sign. Everything on the inside stays the same. Chain. Now I'm going to find the derivative of the inside, the yellow. To find the derivative of the yellow, I need to use the quotient rule. Or sorry, the product rule. So, like Seth was just saying, where does the 2 go? You could put, I would put it at the x, leave it with the x, so 2x times y. So if 2x is the first guy, it's going to be 2x times the derivative of y. The derivative of y is 1 dy dx. So in other words, just dy dx. Plus, reverse it. The derivative of the first, so the derivative of 2x is 2 times y equals. Okay. The derivative of y is just 1 dy dx. So it's got a 1 in front. You can write the 1. You don't have to write the 1. Sometimes it's easier. Sometimes it's not. You know, it's up to you. Okay. So now I got to get dy dx's on the same side. Everything without a dy dx, I got to move to one side. Everything without a dy dx, I'm going to move to the other. Okay, so on this side here, it's important to know what's going on. You have this times this. That's what's going on. Right? Well, this guy here doesn't have a dy dx. So to move it over here, what do I have to do? Add, subtract, multiply, or divide?
Subtract?
No, since it's being multiplied, right? This guy right here is being multiplied with this guy over here, right? Divide, yeah. Before you do that, let's move dy dx to the other side. So you're going to do minus dy dx from both sides. Minus dy over dx from both sides. Oh, wait. No. Sorry. Because I will make a 0.
Yeah.
Okay, so.
Subtract 2y first?
So this is what I'm going to do. I can't subtract dy dx from both sides because then that would leave a 0 over here. And 0 is not wrong with it, but if I want to divide later, I can't divide. I can't have 0 on top when I divide.
Subtract 2y first?
So this is what I'm going to do here. Actually, I'm going to do distributive property. Remember how I said there was multiplication? Remember how I said this was times this? Well, the left has 1 term. The right has 2 terms. So the first thing you're going to do is multiply this times this guy. So negative 2x times sine of 2xy, and then it gets the tag at the end. Okay, so I multiplied this guy. I'll use a different color. Times this guy. That's the first thing I did. That's that term. And then I'm going to multiply the blue times this guy. So it's going to be negative 2y times sine of 2xy. And then the other side stays dy over dx.
Subtract 2y.
So everything, so this is what I'm going to do, yeah. So I need to get the dy dx's on the same side. So you can move this guy over here, or I can move this guy over here. But then if I do that, I got to move this guy over there. It seems like one step will do it. So I'm going to add 2x times sine of 2xy dy dx over here. Because I don't want to break it up yet. I'm not breaking it up yet. All I'm doing is just getting the dy dx's on the same side, or y primes if you use y prime. Okay. This guy goes away. Bring this guy down. Negative 2y times sine of 2xy equals, over here I have dy dx plus 2x times sine of 2xy times dy over dx. So I have two dy dx's on the other side, so the GCF so what's going to be in parentheses? If I take away this guy and I take away this guy,
You can put a 1.
a 1, yeah, it's going to be a 1 there. A 1 plus 2x times sine of x, oops, sorry, not x, 2xy. Divide. You get dy dx. Equals negative 2y times sine 2xy over 1 plus 2x times sine of 2xy. That's as crazy as they'll get. That one is as crazy as they'll get. It's a lot of GCF, getting things, it's a lot of non-calculus stuff. I was done, like I said, again, after that, I was done with calculus. Everything under that box is not calculus. It's just algebra.
Okay, it just looks more complicated than it is. You're just isolating something. Okay. All right. All right. We'll do one more, maybe two, if we have time, but we'll shoot for one more. So number 5. Same thing. This one just has a root attached. Well, we've done derivatives of roots attached. You guys have done that many, many times. So that shouldn't be a problem. So we got to find the derivative of the yellow first. Well, before we even start, right, we got to rewrite it. X plus 2y to the 1/2 power. That's what it is. So to find derivative of it, we got to use the chain rule. So 1/2, everything on the inside stays the same. Oops, subtract a 1/2 power, or a full power. Now I got to find the derivative of the inside. The derivative of the inside is, well, the derivative of x is just 1. The derivative of 2y is just 2 with a tag. Equals. The derivative of this guy is just going to be 5 dy over dx. So I should have done it in calculus is done. Yeah, so I'm going to have to do what I did on the last problem, which is distribute, because I'm going to have the same issue. Okay, so this is where it's going to get a little bit, not complicated, just a little dicey for right now. So distribute it there and distribute it there.
Are we distributing the square root and the negative square root part as well?
Yeah, that's where it gets a little dicey because it's a negative square root we got to distribute. So whatever's on the outside, what is on the outside? 1/2 time, anything times 1 repeats itself. So the first guy is just going to repeat itself. Plus. All I did was multiply this guy times this guy. Anything times 1 is just repeats itself.
Because you're doing that, everything's just multiplied by 2?
Yeah, so the other one is just 2 dy dx, right? So this guy is going to multiply times this guy. So instead of a 1, they have a 2, so it's just going to double.
So it's just going to be
What?
the 1/2?
Yeah, what's 1 times 1/2? 1, right? So it's not going to have a 1/2 in the front. It's going to have an x plus 2y negative 1/2, and then it'll have the tag. The other side stays the same because I haven't done anything with the other side. Okay. This guy right here, this term right here, and this term right here have dy dx's. I need them on the same side of the blue line. So I'm going to move this guy over here. So to do that, how do I do that? Add, subtract, multiply, or divide?
Subtract?
Subtract, yeah. Subtract because it's positive.
these guys go away. So now this guy's going to come down 1/2 x plus 2y negative 1/2. Then I have a 5 dy dx minus dy dx.
You get dy dx out of the equation?
Factor out of dy dx, divide, you're done.
Oops, forgot to put a 1 in over here, -1. So that would be 5 minus x plus 2y negative 1/2. Divide by what I don't want to stay. I want dy dx to stay. I don't want anything else to stay. Okay, so I have 1/2 x plus 2y negative 1/2 over 5 minus x
What
plus
does the 2 go on the bottom?
2. So you could move it to the bottom, but then you would have to distribute it to both terms because there's 2 terms on the bottom. You could do that. But there's 2 things on the bottom. There's a 5 and there's a x plus 2y to the negative 1/2.
Because the negative 1/2 wouldn't we have to move down or no?
Yeah, I mean, they would switch spots because they're both negative. I'm not worried about that right now. I'm just worried about isolating dy dx. I'm going to stop there because you're just isolating. Yeah. So 1/2, wouldn't I move the 2 to the bottom? Yes, you could. But then you would have to multiply it times this guy, which would make 10, and then the 2 would go in front. And then don't both of these guys have negative exponents? Yeah, this guy would move down, this guy would move up. So they'd switch spots.
Would they ever ask us to simplify it?
They might if it's multiple choice. They might. There was one question that was giving you guys some trouble I saw on the multiple choice, which was, it was like x squared times a root. And a lot of you were doing the calculus part right. A lot of you nailed the calculus part. You found the derivative, boom, I have the derivative. You just weren't able to match it to one of the 5 answers. And that's where you guys got tripped up. So sometimes, like I said, sometimes that's the hardest part. The calculus you guys nail. It's the other stuff that sometimes are difficult.